Hi children, how are you? Again with one more online video class. I am virtually present in front of you. Good morning. So we are in the lesson laws of motion, and this will be the last part of this lesson. In the last part we have learned an action and reaction forces lab activity related to Newton's third law of motion and an application for Newton's second law, that is conservation of linear momentum, we have discussed in the last session. So today uh, we have to discuss related to one more application using Newton's second law. In this part with some examples. And one more point, children, please keep in the mind that whoever have to complete any of the incomplete parts assignments, please try to complete them. Why? Because after two revisions, you have to write the CT. So please everyone sincerely do the work. You cannot quit the lessons, children. You have to do it now. Please be sincere. Generally, what happens when you're walking on the road? So if you do not come across an obstacle on the way, you may hit it and fall down and you may get hurt yourself. But here, as he is doing, who is here? A pole vaulter is jumping from the pole vault onto the ground. But he will not jump on the ground. If you see carefully, it is like a cushion bed. So there is a reason for this pole vault jumper landing on a thick mats of foam. Unlike when we walk on the road, if we are hit by an obstacle, we get hurt ourselves. But here in this case, he may not hurt himself. Len, do you know what is this picture? This picture is related to long jump. Here, after a jump, the person is landing safely on a sand bed. You know, he's safe after he jump also. In general, what happens if you are jumping and you know small children, if they jump on the floor for many times, if they fall down, they get hurt. But here, sports person, this person will not get hurt himself. So in order to avoid hurting the sport person, they will arrange a sand bed. Do you know these two games and sports are related and you have seen in Olympic games? You- So many games are to be conducted in Olympics actually. So actually this is the year of 2020. Olympics should be conducted because of Corona. They did not conduct. You know, I hope we'll see in the next year those games. Next time you observe all the games and sports, how many they are conducted and what is the setup they are making for each games and sport. Okay, so I have given two cases. One is a pole vault jump, the other one is long jump. So in a pole vault, the person lands on a mattresses type related to cushion. In the high jump, the person lands on the sand. So what happens here? That is where the persons or the people who are doing the act, who are participating in that sports or games, they will not be um, hurt themselves. So a softer and a more cushion landing surface provides a greater stopping distance because of longer time taken to stop. So this leads to the rate of change of momentum will be less. So what is momentum? You know, that is product of mass in velocity. Rate of change of momentum means uh, his body will have some mass. So initially he will be traveling, his movement will be with some velocity. After landing, he will decrease to some velocity. So for that reason, rate of change of momentum will be less. so that the force of impact will be decreased. So thereby the person who lands in these two situations, he will not hurt himself. In the Newton's second law of motion, we have discussed an equation F is equal to ma. And in two ways I have told, this also I have told, F net is equal to delta P by delta T. This is related to Newton's second law. So what is that? In order to minimize F net, you have to maximize the stopping force. So whatever the discussions we have done up to now, it is related to this only. If you see the equation, F net is equal to delta P by delta T. F net is directly proportional to delta P. What is directly proportional? If one quantity increases, the other quantity increases. F net means a force application increases, a change in momentum also will be more. And the other relation what you'll see is F net is inversely proportional to delta T. What is delta T? Delta T is nothing but interaction time. If you decrease the time, uh, force of impact will be more. If you increase the time, force of impact will be less. And one more condition you have to keep in the mind that change in momentum is constant. If at all a change in momentum is changing, then whatever the case I explained, it will not happen so. So that's the reason I told you. In order to minimize F net, you have to maximize the stopping force. So when you multiply F net into delta T, that equal to delta P. You know that. So the product of net force and interaction time is called the impulse of net force. Now you have to remember what is impulse now. So indirectly impulse delta P is equal to F net into delta T. So what is the delta T? Interaction time. Interaction means when a body is in touch with any other body. Here, impulse is equivalent to change in the momentum that an object experiences during an interaction. So here, impulse is represented with J, and J is equal to here F into T. Here you have to take what is this F? Nothing but your F net only. We know that F net is equal to change in momentum by time taken. If I have taken F is equal to change in momentum means I can apply m into v minus u. So that is m into v minus u by t and into t, and both the t gets cancels. You are left with m into v minus u. So that's the equation where I have written j is equal to m times of v minus u. If you take final momentum as Pf and initial momentum as Pi, then the impulse is equal to Pf minus, what is that? Final momentum minus initial momentum. So that's the thing related to your expression equivalent to change in momentum during an object experiences with the body. So now when it comes to SI unit, a Newton second, because you remember delta P is equal to, I told, F net into delta T. So F net is always force. It is represented with the Newton times second. So that is reason Newton second. So similar, it is a similar unit to your linear momentum. I hope you have remembered this. And since it gives a direction, this impulse will be a vector quantity. So up to now we have learned related to impulse. So forces exerted over a limited time are called impulsive forces. In general, we can call them as impulse. Often the magnitude of an impulsive force is so large that its effect is appreciable even though its duration is very short. So actually you have to remember the relation. What is that? F net is equal to delta P by delta T, or F net into delta T is equal to delta P. If you remember this, you can understand the concept. So what you're watching in the picture uh, is dropping of eggs. So you have to take two eggs and drop them from a certain height such that one egg falls on a concrete floor and another egg falls on a cushioned floor. So what changes do you notice in both the eggs after they're dropped? Children, please don't do this type of activities in the house and don't make your parents to uh, scold you all. Okay, I also did not try this activity until now. I'm doing a few activities in the house, but I did not try this activity in my house. Okay, you also please don't do it. Just observe what I am telling. So when we drop an egg on the concrete floor, it will break because the large force acts on the egg for a short interval of time. I told you to remember the equation. So delta P is equal to F net. See, the representation of F net is more into delta T. When we drop egg on a cushion, so it does not break because the smaller force acts on the time for a longer time. So here also the same equation, delta P is equal to F net into delta T. Here delta T is represented with a big one to indicate it is a longer time. And the last you have to remember that even if the delta P is same in both the cases, the magnitude of a net force acting on the egg determines whether the egg will break or not. So on the whole, you have to remember in such a way that change in momentum not only depends on the magnitude of force, but also on the time during which the force is exerted on the object. Nothing but in general, we call it as an interaction time. In today's class, to understand about impulsive force in general impulse, we have discussed about two games. And not only that, dropping of X activity also we have discussed. With that, I wind up the lesson loss of motion with this online video. Please, you all rewatch all the videos what are there related to this lesson once again and get prepared for the CT. So thank you children. Have a good day.